In this video, we'll be solving the integral of x squared all over square root of x squared plus 4. The first thing we're going to do is we're going to let x equal 2 tangent theta. So dx will be 2 secant squared theta d theta. So now we can replace this integral in terms of thetas, and x squared will be 4 tangent squared theta. Dx will be 2 secant squared theta d theta. And we can simplify this and see that, well, at the top we have 4 tangent squared times 2 secant squared. That's going to give me 8. And the denominator, 4 tangent squared plus 4, we can pull out the square root of 4 and it will be 2. So 8 over 2 will be 4. So this will just be 4 times the integral of tangent squared secant squared over the square root of tangent squared plus 1. Now tangent squared plus 1 is secant squared. So the square root of secant squared is secant. And so secant squared over secant will just be secant. And now we're going to make a substitution. We know 1 plus tangent squared is secant squared. So tangent squared will be secant squared minus 1. So we're going to multiply the secant with the secant squared minus 1. And we're going to get secant cubed minus secant. We're going to break this up into 2 separate integrals. So the first integral will be with secant cubed, and then the other one will be with secant. And in order to solve the integral of secant cubed d theta, we're going to use a reduction formula. And recall, the formula says if I have the integral of secant to the m, and here, because we're looking at cubed, it's going to be 3. So secant to the m x dx is equal to sine x times secant to the m minus 1 x over m minus 1 plus m minus 2 over m minus 1 times secant to the negative 2 plus m x dx. So when I use that for secant cubed, I get sine theta times secant squared over 2 plus the integral, plus 1/2 times the integral of secant theta d theta. And now I'm going to subtract it with the second integral, which is secant theta d theta. So I combine everything inside the parentheses. So the 1/2 integral secant theta minus secant theta is just negative 1/2 integral secant theta d theta. I distribute the 4 and I get negative 2 integral secant theta d theta. And the first term will be 2 tangent theta secant theta, since the 4 over 2 simplifies to 2. And in order to solve the integral now of just secant theta, I'm going to multiply top and bottom by secant plus tangent. Because when I do that, I get secant squared plus secant theta tangent theta over secant plus tangent. And this actually works really nice because I can make a substitution now and let u be the denominator. So secant theta plus tangent theta. And du will be the numerator. So the integral simplifies to du over u, which is just ln of u. And u we said is secant plus tangent, so we plug that in. And now my expression depends on theta. Originally, the question was only in terms of x. So we want to go back to x first. In order to do that, we need to get a right triangle. And I know that way back we let x equal, or that tangent theta is x over 2. Or x equals 2 tangent theta. So that was a substitution we made. And tangent is opposite over adjacent. So if we do the Pythagorean theorem, we get the square root of x squared plus 4 is the hypotenuse. And so now I'm going to replace tangent and secant in terms of x based off this right triangle. So tangent theta will be x over 2. Secant theta will be square root of x squared plus 4 over 2. And so that is my final answer.